Hello viewers, welcome to my channel Maths with VTC. In this video class, we are going to see exercise 5.3. This exercise has many problems, therefore we solve the problems very quickly, okay? First, find the sum of the following arithmetic progressions. So for each arithmetic progression, you have to find a first term, common difference, and then number of terms. Then you can substitute all the values in the formulas, then you can write the answer easily. Let us look at the first problem. A is equal to 2, D is equal to 5, and N is equal to 10. Therefore, in the formula Sn is equal to n by 2 into 2a plus n minus 1 into d, we substitute all the values. Therefore, S10 is equal to, we get 245. So it is merely simplification. You must be able to find the value of A, value of D, and value of N. Then substituting these values, you can find S10. It is only simplification. Next, a similar problem. A is equal to minus 7, D is equal to 4, and N is equal to 12. Therefore, in the formula, when you substitute all these values, you get S12 is equal to minus 180. Okay. Third problem, A is equal to 0.6, D is equal to 1.1, N is equal to 100. You must know how to find D. A2 minus A1 or A3 minus A2, if you write, you will get D is equal to 1.1. Substituting all the values in the formula, you get S100 is equal to 5,505. So it is very simple. You have to carefully substitute the values and carefully simplify without committing any mistake. Okay. Fourth problem. For this arithmetic progression, A is equal to 1 by 15, D is equal to 1 by 60, and N is equal to 11. Substituting these values in Sn, you get S11 is equal to 33 divided by 20. So you have to substitute those values and simplify without committing any mistake. So you will get the answer as 33 divided by 20. Okay. Second sum. Find the sums given below. So we are given three arithmetic progressions. The difference between the previous problem and this problem is, in the previous problem, number of terms were given. But here, the last term is given. So you have to use the another formula for Sn. Okay. For this arithmetic progression, A is equal to 7, D is equal to 7 by 2, and L is equal to 84. So the last term is given. It is 84. So only when you know the value of N, you can find the sum. So you assume that there are n terms in the arithmetic progression. Therefore, nth term is 84. So if you use the formula, you get 84 is equal to 7 plus n minus 1 into 7 by 2. Therefore, n minus 1 is equal to 22 or n is equal to 23. Now you can use the other formula for Sn. Sn is equal to n by 2 into a plus l. When you substitute the values, you get S23 is equal to 1046 and half. So that is the answer. So it is very simple. Anyway, you have to find out n. After finding n, you use the formula Sn is equal to n by 2 into a plus l. Okay. Second problem. A is equal to 34, D is equal to minus 2, L is equal to 10. Therefore, you assume as usual there are n terms and the nth term is 10. So what is the value of n? It is 13. So you have to find S13. So S13, the formula is 13 by 2 into 34 plus 10. When you simplify, you get the answer as 286. Third problem. For this arithmetic progression, A is equal to minus 5, D is equal to minus 3, and L is equal to minus 230. We have to find out the summation. So you need the number of terms. Though last term is given, you must find the number of terms in the arithmetic progression. So we assume that n terms are there. And what is nth term? It is minus 230. When you equate this to the formula, you get minus 5 plus n minus 1 into minus 3 is equal to minus 230. When you simplify, you get n is equal to 76. Therefore, S76 is equal to 38 into minus 235, which is equal to minus 8,930. So without committing mistake, you have to solve the problem. You have to write steps like this. Then only you will not commit any mistake. If you skip any step, there may be chance for committing mistakes. Okay. Third problem. In an arithmetic progression, given A is equal to 5, D is equal to 3, AN is equal to 50. Find n and Sn. Solution. If an is equal to 50, then 50 is equal to 5 plus n minus 1 into 3. You know the formula. So when you simplify, you get n is equal to 16. When you know n is equal to 16, you can find S16. S16 is equal to 16 by 2 into first term plus last term. Therefore, S16 is equal to 440. Second problem. Given A is equal to 7, A13 is equal to 35. Find D and S13. So A13 is equal to 35 means 35 is equal to 7 plus 13 minus 1 into D, because that is the formula. AN is equal to A plus n minus 1 into D. When you simplify, you get D is equal to 7 by 3. So D is found. Now S13 is equal to 13 by 2 into first term 7, last term 35. So when you simplify, you get the answer as 273. Third problem. Given A12 is equal to 37, D is equal to 3. Find A and S12. So A12 is equal to 37 implies A is equal to 4 because D is given. So S12 is equal to 12 by 2 into first term plus last term, that is 4 plus 37. So when you simplify, you get 246. Fourth problem. Given A3 is equal to 15, S10 is equal to 125. Find D and A10. So A3 is equal to 15 gives 15 is equal to A plus 2D. You call this equation as 1. S10 is equal to 125. This gives 125 is equal to 10A plus 45D. You call this as equation 2. Now, by elimination method, we can find the values of A and D. So 2 minus 10 into 1. Equation 2 minus equation 1 multiplied by 10 gives minus 25 is equal to 25D, or D is equal to minus 1. Therefore, A is equal to 17. Therefore, A10 is equal to A plus 10 minus 1 into D, which is equal to 17 minus 9, which is equal to 8. Hence, D is equal to minus 1 and A10 is equal to 8. Fifth problem. D is equal to 5. S9 is equal to 75. Find A and A9. So, S9 is equal to 75 implies 75 is equal to 9 by 2 into 2A plus 9 minus 1 into 5. When you simplify, you get 150 is equal to 18A plus 360, or A is equal to minus 15 by 3. Therefore, A9 is equal to 85 by 3. Thus, A is equal to minus 35 by 3 and A9 is equal to 85 by 3. Sixth problem. Given A is equal to 2, D is equal to 8, Sn is equal to 90. Find N and An. Sn equal to 90. Then 90 equal to n by 2 into 2 plus n minus 1 into 8. Or 90 is equal to 4n square minus 2n. When you simplify, you get 2n square minus n minus 45 is equal to 0. So when you separate the middle term, you get 2n square minus 10n plus 9n minus 45 is equal to 0. Therefore, this can be factored as n minus 5 into 2n plus 9 equal to 0. Therefore, n equal to 5 is the only possible value, because n is equal to minus 9 by 2 is inadmissible. N cannot be negative. as well as n cannot be fraction. Okay. So n is equal to 5. Therefore, what is a5? A plus 5 minus 1 into d. Therefore, it is 34. Thus, n is equal to 5 and a5 is equal to 34. Seventh problem. A is equal to 8, an is equal to 62, Sn is equal to 210. Find n and d. So, an is equal to 62 gives 54 is equal to n minus 1 into d. Sn is equal to 210. This implies 420 is equal to n into 4 plus n minus 1 into d. So using 1 in 2, we get 420 is equal to n into 16 plus 54, or n is equal to 420 divided by 70, or n is equal to 6. Therefore, d is equal to 54 by 5. Thus, n is equal to 6 and d is equal to 54 by 5. Okay. Eighth problem. Given an is equal to 4, d is equal to 2, Sn is equal to minus 14. Find n and a. So, similar problems. So, an is equal to 4 gives a is equal to 4 minus 2 into n plus 1. Sn is equal to minus 14. This gives minus 28 is equal to n into 2a plus 2 into n minus 1. In order to substitute 1 in 2, I have written like this. You should not simplify the equations 1 and 2. If you keep like this, you can solve 1 and 2 easily. Using 1 in 2, we get minus 28 is equal to n into 8 minus 4 into n minus 1 plus 2 into n minus 1. When you simplify, you get n is equal to 7 or n is equal to minus 2. Obviously, n is equal to minus 2 is not possible. Therefore, we take n is equal to 7. When you substitute n is equal to 7 in equation 1 or 2, you get a is equal to minus 8. Thus, n equal to 7 and a is equal to minus 8. Ninth problem. Given a is equal to 3, n is equal to 8, s equal to 192. S means sum of n terms. Sometimes it can be written like this. Instead of Sn, we may write S also. Okay. So S is equal to S8 because n is equal to 8, which is equal to 192. When you substitute these values in the formula, you get 192 is equal to 4 into 6 plus 7d, or d is equal to 6. 10th problem. Given L is equal to 28, S is equal to 144. Total number of terms is 9. Find A. So S is equal to S9, which is equal to 144. When you substitute these values in the formula, you get A is equal to 36 by 4. Thus, A is equal to 4. Fourth sum. How many terms of the arithmetic progression 9, 17, 25 must be taken to give a sum of 636? So we assume that sum of first n terms is equal to 636. Then our duty is to find the value of n. So here A is equal to 9, B is equal to 8. Putting these values in the formula, we get a quadratic equation n. 4n square plus 5n minus 636 is equal to 0. So when you use the formula minus b plus or minus b square minus 4ac by 2a, you get n is equal to minus 106 by 8 or 12. Since n cannot be negative or fraction, we take n is equal to 12. Therefore, first 12 terms are added to get 636. So that is the answer. Fifth problem. The first term of an arithmetic progression is 5. The last term is 45 and the sum is 400. Find the number of terms and a common difference. So, we assume there are n terms. A is equal to 5, L is equal to 45 and S is equal to 400. So, you will get an equation like this. 400 is equal to n by 2 into 5 plus 45. Therefore, n is equal to 16. Since the last term is 45, A16 is equal to A plus 16 minus 1 into D. Therefore, D is equal to 8 by 3. Hence, N is equal to 16 and D is equal to 8 by 3. Sixth problem. The first and the last terms of an arithmetic progression are 17 and 350 respectively. If the common difference is 9, how many terms are there and what is their sum? Okay. A is equal to 17, L is equal to 350 and D is equal to 9. Suppose there are n terms, then an is equal to a plus n minus 1 into d. Therefore, 350 is equal to 17 plus n minus 1 into 9. When you simplify, you get n is equal to 38. Therefore, S is equal to 6973. So, simply you have to substitute the values in the formula. Okay. Seventh problem. Find the sum of first 22 terms of an arithmetic progression in which d is equal to 7 and 22nd term is 149. So given n is equal to 22, d is equal to 7, a22 is equal to 149. Simply substitute those values in the formula of a22. Then you get a is equal to 2. Therefore, s22 is equal to 1661. Simply I have put the values of a, n, d in the formula of Sn. That's all. Eighth problem. Find the sum of first 51 terms of an arithmetic progression whose second and third terms are 14 and 18 respectively. So A is not given, D is not given. Instead of second term is given, third term is given. So we find the values of A and D using these two facts. A2 is equal to 14, A3 is equal to 18. Therefore, D is equal to A3 minus A2, which is equal to 18 minus 14, which is equal to 4. Hence, the first term A1 is equal to 14 minus 4, which is equal to 10. So, A is known, D is known, N is also known. Therefore, S51 is equal to 5610. So, just a simplification. Okay, if you understand the problem, then you can easily solve what is given, what is required. Okay. Ninth problem. If the sum of first 7 terms of an arithmetic progression is 49 and that of 17 terms is 289, find the sum of first n terms. So S7 is equal to 49 and S17 is equal to 289. So when you substitute those values in the formula, you get one equation. 49 equal to 7a plus 21d. Similarly, using the other information, you get another equation. 289 is equal to 17a plus 136d. So the rest of the job is to find the values of a and d using elimination method. Therefore, I get d is equal to 2 and a is equal to 1 when I solve like this. Okay. Thus, Sn is equal to, simply it is n square. Okay. 10th problem. Show that A1, A2, An form an arithmetic progression where An is defined as below. An is equal to 3 plus 4n. So, An is equal to 3 plus 4n means A1 is equal to 7, A2 is equal to 11, A3 is equal to 15 and so on. So 7, 11, 15. Obviously, it is an arithmetic progression. Therefore, A is equal to 7 and D is equal to 4. Therefore, Sn you have the formula. Therefore, S15 is equal to 525. In the same way, you can solve the second problem also. So A1 equal to 4, A2 equal to minus 1, A3 is equal to minus 6. So what is A? 4. What is D? Minus 5. Therefore, S15 is equal to minus 465. That's all. 11th problem. If the sum of the first n terms of an arithmetic progression is 4n minus n square, what is the first term? What is the sum of first two terms? What is the second term? Similarly, find the third, the 10th and nth terms. Solution. Sn is equal to 4n minus n square. Therefore, S1 is equal to A1, which is equal to 3. S2 is equal to A1 plus A2, which is equal to 4. Therefore, S2 minus S1 will give you A2, which is equal to 1. Thus, An is equal to Sn minus Sn minus 1, which is equal to 4n minus n square minus 4 into n minus 1 minus n minus 1 whole square. On simplification, you get An is equal to 5 minus 2n. Now you can verify A1 is equal to 3 and A2 is equal to 1. So A3 is equal to minus 1. A4 is equal to minus 3. A10 is equal to minus 15. Twelfth problem. Find the sum of the first 40 positive integers divisible by 6. The first positive integers divisible by 6 are 6, 12, 18, 24 and so on. So clearly it is an AP with the A is equal to 6, D is equal to 6. We are given N is equal to 40. Therefore, S40 is equal to, and simplification you get, it is 4920. Okay. Find the sum of the first 15 multiples of 8. The multiples of 8 are 8, 16, 24, 32. Clearly it is an AP with the A is equal to 8 and D is equal to 8. We have Sn is equal to n by 2 into 2a plus n minus 1 into D. Here n is equal to 15. Therefore, S15 is equal to 960. So that is the answer. 14. Find the sum of the odd numbers between 0 and 50. The odd numbers between 0 and 50 are 1, 3, 5 to 49. Clearly, it is an arithmetic progression with the A is equal to 1, L is equal to 49 and D is equal to 2. So, what is required? Sum of all the odd numbers between 0 and 50. So, let there be n terms. Then An is equal to 49. This gives n is equal to 25. Therefore, S25 is equal to, when you simplify, you get it is 625. So that is the value of S. 15. A contract on construction job specifies a penalty for delay of completion beyond a certain date as follows. Rupees 200 for the first day. Rupees 250 for the second day, rupees 300 for the third day, etc. The penalty for each succeeding day being rupees 50 more than for the preceding day. How much money the contractor has to pay as penalty if he has delayed the work by 30 days? The problem seems to be big. Actually, it is very simple and easy to solve. Okay? Let us see. The penalties for first, second, third, fourth days are as follows. 200, 250, 300, 350 and so on. Clearly, it is an arithmetic progression with A is equal to 200, D is equal to 50. We are required to find S30. S30 is equal to, when you substitute those values in the formula, you get, it is rupees 27,750. Okay. Only problem is lengthy. Solution is very simple. 16th problem. A sum of rupees 700 is to be used to give 7 cash prizes to students of a school for their overall academic performance. If each prize is rupees 20 less than its preceding price, find the value of each of the prizes. Solution. Let the price amounts be A minus 20, A minus 40 and so on to A minus 120. Okay. Therefore, D is equal to minus 20, N is equal to 7 and S is equal to 700. By the formula Sn is equal to n by 2 into 2a plus n minus 1 into D, we have A is equal to 160. Therefore, the value of each of the prices are 160, 140, 120, 100, 80, 60 and 40. 17th problem. In a school, students thought of planting trees in and around the school to reduce air pollution. It was decided that the number of trees that each section of each class will plant will be the same as the class in which they are studying. For example, a section of class 1 will plant one tree. A section of class 2 will plant two trees and so on till class 12th. There are three sections of each class. How many trees will be planted by the students? Here also the problem seems to be big, but the answer is very simple. The trees planted by three sections of class 1 to class 12 will be 3, 6, 9 to 36. It is an arithmetic progression with the A is equal to 3, L is equal to 36, D is equal to 3 and N is equal to 12. Therefore, S is equal to, when you substitute the values, you get it is 234. Therefore, the total number of trees planted will be 234. 18th. A spiral is made up of successive semicircles with the centers alternatively at A and B, starting with the center at A of radii 0.5 cm, 1.0 cm, 1.5 cm, 2.0 cm and so on, as shown in the figure. What is the total length of such a spiral made up of 13 consecutive semicircles? You look at this diagram, okay? Now it is clearly understandable. The length of a semicircle with the radius r is pi r. Actually, for a circle, circumference is 2 pi r. Since it is semicircle, only you have to consider half of that. Therefore, it is pi r. Now, the first semicircle radius is 0.5. Therefore, it is 0.5 pi. Second semicircle radius is 1. Therefore, it is pi. Third semicircle it is 1.5. Therefore, the length is 1.5 into pi and so on. Clearly, it is an arithmetic progression with the A is equal to 0.5 pi, D is equal to 0.5 pi and N is equal to 13. So just substitute these values in the formula, you get S is equal to 143 centimeter. So very simple. Okay. 19th problem. 200 logs are stacked in the following manner. 20 logs in the bottom row, 19 in the next row, 18 in the row next to it and so on. In how many rows are the 200 logs placed and how many logs are in the top row? You look at this diagram. Now you can understand. The logs are arranged in this way. The bottom row contains 20 logs. Above that 19. Above that 18 and so on. Okay. So how many rows required to arrange 200 logs? So that is the question. The number of logs from the bottom are 20, 19, 18 and so on. Clearly, it is an arithmetic progression with the A is equal to 20, D is equal to -1 and S is equal to 200. Sum is equal to 200. Only thing we have to find out N, that is number of rows. You substitute these values in the formula, you get a quadratic equation in N, that is N square minus 41N plus 400 is equal to 0. When you solve this, you get N is equal to 16 or 25. But when N is equal to 25, we get AN is equal to -4, which is not possible. Negative number of logs is not possible. Therefore, we neglect the case N is equal to 25. Therefore, we consider N is equal to 16 and A16 is equal to 5. So, that is the answer. Therefore, there are 16 rows and 5 logs placed in the top row. Last problem. In a potato race, a bucket is placed at the starting point, which is 5 meters from the first potato. and the other potatoes are placed 3 meters apart in a straight line. There are 10 potatoes in the line. A competitor starts from the bucket, picks up the nearest potato, runs back with it, drops it in the bucket, runs back to pick up the next potato, runs to the bucket to drop it in, and she continues in the same way until all the potatoes are in the bucket. What is the total distance the competitor has to run? Okay. You look at this diagram. This will explain you clearly. She starts from the bucket. So first to reach the first potato, she runs 5 meters. Back to the bucket again 5 meters. So for the first potato, total distance covered is 10 meters. For the second potato, 5 plus 3, 8. Back 8, so 16. Third potato, 5 plus 3 plus 3, 11, plus 11, 22, and so on. Okay. So for the first potato, 10 meters, second potato, 16 meters, third potato, 22 meters, and so on. Clearly, it is an arithmetic progression with the A is equal to 10, D is equal to 6. It is very clear. Now, sum of all these numbers will give you the total distance covered by her. Okay. So, yes, 10 is equal to 10 by 2 into 2a plus 10 minus 1 into d. So, when you substitute those values, you get s is equal to 370. Therefore, the distance covered by the little girl is 370 meters. Exercise 5.4. It is given as optional, but anyway, we will solve all the problems given in this exercise too. Okay. First problem. Which term of the arithmetic progression 121, 117, 113 is its first negative term? So it is decreasing. At one stage, it will reach negative number. So what is the first negative number? So what we do is, we take the nth term and assume that it is negative. For which minimum value of n, it is negative. So that will give you the first negative term. So that is the idea. So obviously A is equal to 121, D is equal to minus 4. So what is AN? AN is equal to A plus n minus 1 into D. I assume that it is less than 0. Okay, this gives 125 is less than 4n, or 125 by 4 is less than n. That is 41.25 is less than n. What is the minimum value of n satisfying this inequality? Clearly 42. You can take 43, 44, 45. All those values will satisfy this inequality. But we need the minimum value of n. Therefore, it is 42 only. Okay. So, 42nd term is the first negative term. Second problem. The sum of the third and the seventh terms of an arithmetic progression is 6 and their product is 8. Find the sum of first 16 terms of the arithmetic progression. So what is given? Write it first, okay? Given a plus 2d plus a plus 6d is equal to 6. This is given. So on simplification, I get a is equal to 3 minus 4d. I call this as equation number 1. Next, its product is equal to 8. So I call this equation as 2. Using 1 in 2, we get d is equal to plus or minus 1 by 4. So when you have two values for d, naturally by 1 you will have two values for a also. So when d is equal to 1 by 4, a is equal to 2. And when d is equal to minus 1 by 4, a is equal to 4. Therefore, s is equal to, for the first arithmetic progression, it is 76. For the second arithmetic progression, it is 20. You can easily calculate it because a is known, d is known, n is also known. Therefore, for the first case, s is equal to 76, and for the second case, s is equal to 20. Okay. Third problem. A ladder has rungs 25 centimeter apart. The rungs decrease uniformly in length from 45 centimeter at the bottom to 25 centimeter at the top. If the top and the bottom rungs are 2.5 meters apart, what is the length of the wood required for the rungs? So you have to add all the lengths of the rungs. Here, the length of the rungs from bottom to top will follow a pattern. The lengths will be an arithmetic progression. Okay. You see this diagram. So total length is 2.5 meters. For each 25 centimeter, there is one rung. Therefore, how many rungs will be there? 250 divided by 25 plus 1. You have to add 1. Okay. Therefore, for this AP, we know A is equal to 45, L is equal to 25, and N is equal to 30. So we have to find the lengths of all rungs. So S is equal to N by 2 into A plus L. So it is 385 centimeter. Therefore, the length of the wood required for the rungs is equal to 385 centimeter. Fourth problem. The houses of a row are numbered consecutively from 1 to 49. Show that there is a value of x such that the sum of the numbers of the houses preceding the house number x is equal to the sum of the numbers of the houses following it. Find this value of x. So you understand the problem carefully. So 1 to 49. In between you have one x. Before that you sum all the terms. After that you sum all the terms. Both are equal. Okay. So the house numbers are 1, 2, 3, x minus 1, x plus 1 to 49. Okay. Now, sum of this and the sum of this both are equal. In that case, what is the value of x? That is the question. So, A is equal to 1, D is equal to 1. Given S49 is equal to Sx plus Sx minus 1. Okay. You understand this carefully. Total sum is S49. So S49 equal to Sx. Up to this, it is Sx. Sx minus 1. Actually, we have to add this, but it is same as Sx minus 1. Therefore, S49 is equal to Sx plus Sx minus 1. That's all. Now you can substitute the formula and the values. You will get the value of x. X is equal to 35. So that is the answer. Okay. Last problem. A small terrace at a football ground comprises of 15 steps, each of which is 50 meter long and built of solid concrete. Each step has a rise of 1/4 meter and a tread of half meter. See the figure. Calculate the total volume of concrete required to build the terrace. Okay. You look at the problem carefully and see the diagram also. For the first step, what is the volume? That will give you the amount of concrete. For the second step, what is the volume? So, you have to calculate in such a way. Okay, let us calculate the first step's volume. The volume of first step is 1/4 into half into 50 because it is height, it is breadth, it is length. So it is 6.25 meter cube. Similarly, for the second step, height is increased, it is half. Width is same, length is same. So it is 12.5 meter cube. Third step, again height is increasing by 1/4 meter. Therefore, it is 18.75 meter cube. Therefore, it is an arithmetic progression. You know A, you know D. When you substitute those values in the formula of S, you get this. When you reduce, you get S is equal to 750. Therefore, the total volume of concrete required to build the terrace is 750 meter cube. So that is the answer. Thank you viewers for watching this video. Please don't forget to subscribe and share this video to your friends too. Thank you.